Okay, good morning. Welcome to
SummerMath number 29.
Okay, so this morning you were working on the 2012 AMT8, and this problem gave you a little bit of difficulty. And just by coincidence, it's similar to the family math we did yesterday about primes and factoring. Okay, so here's the question. What is the smallest positive integer that is neither prime nor square and has no prime factors less than 50? Okay, so let's just walk through this. What does it mean that it's not prime? It's neither prime nor square, so it's not prime. What does that mean for a number to not be prime?
Well, it's factors. The number of factors is more than 2.
Okay, so it's got more factors. What about not being a square? What does that mean?
Well,
Your brother?
it means that if you divide it by some number and you get the same number,
Okay.
we can't have that.
What does it mean in terms of factors?
It means it has an odd number of factors. I mean, an even number of factors.
Okay, it means it has an even number of factors. And it means that, also very simply, there's no number that when you square it, you get that number.
Yeah.
Okay? Alright?
Yeah.
So we're trying to find the smallest positive integer that is neither prime, so that means it's got more than one factor.
More
More
than
than
2
2.
because of the 1.
Right, more than 2. So more than one factor bigger than 1. And not a square. And it has no prime factors less than 50.
Well, I think the way to do this is you got to find the smallest primes that are bigger than 50.
What do you think about that?
We can try that.
So let's just say for fun that 52 and 54 were prime, even though they're obviously not. Why not?
Yeah, because they're even.
They're even. Okay. Suppose 52 and 54 were prime, and we multiplied these two together to get some number. Why would this satisfy this?
Because these 52 doesn't equal 54.
Okay.
Yeah.
And these you're multiplying two numbers together, so it's obviously not prime.
Okay.
Yeah.
Make sense?
Yeah.
And why is it the smallest?
Because with those might be the first two primes after 50.
Okay, so let's try to find the first two primes after 50.
I think 53 is
Less
one.
than 50, well it doesn't matter because 50 is not prime, so 52, 53, 54, 55, 56, 57, 58, 59, 60. What numbers can we cross off very quickly because we know they're not prime?
We can cross off all of the even numbers.
All the evens, okay.
Then we can do the multiples of 3.
Well, are there any others that are obviously not prime?
51.
Okay, why?
It's divisible by 3.
Okay, why is that divisible by 3?
Because if you add the digits, that gets to 6.
Okay.
And 55 is divisible by 11.
What else is 55 divisible by?
55, it's divisible by, 5.
5. Okay. So here are our choices. 53, 57, 59.
57 is divisible by 3.
57 is divisible by 3. Okay.
So I think we nailed it here.
Alright, so now our 53 and 59 prime, you got to check up to the square root, right? So
That would mean up to 11. Well, not including 11.
what's the nearest number
8.
that's bigger than this? So you got to check up to 8. So we just have to check 2, 3, 5, and 7. Well, 2, no. 3, no. Adds up to 8, adds up to 14. 5, no.
No.
What's the rule for 5?
It ends in a 5 or a 0? No.
Okay, so now
63 is divisible by 7.
63 is divisible by 7.
And if we,
So that would mean 56 is divisible by 7.
56 is what?
It's 7 times 8.
8 and neither of them.
Okay, so there we go. So we got our two primes, and now we just have to multiply them together. 53 times 59. And we're not gonna do that. Whatever that number is,
That's our answer.
that's our answer. Make sense?
Yeah.
Okay, so hey, that's funny. It was a nice problem, by the way, and very similar to what we did yesterday. Okay, all right, off you go.